Hello, I wanted to explain those last two examples we did in class in a little bit more detail. If we look at this, it says light from the sun traveling at a rate of 300,000 kilometers per second reaches Earth in 499 seconds. Find the distance expressed in scientific notation from the sun to Earth. Like we said in class, we're going to use that expression distance equals rate times time. So they gave us the rate, 300,000 kilometers per second, and they gave us the time, the 499 seconds. So we know that we're going to have to do the 300,000 times 499. If you'd like to work it with those numbers, when you multiply out, you will get this large number. And notice that they tell us to express our answer in scientific notation from the sun to the earth. So we need to write this answer in scientific notation. In this large number, the decimal point is at the end. And we want our decimal point between the 1 and the 4 so that there is one digit before it. So if we look at that, that's 8 spaces from where our new decimal point is over to where it was in decimal form. So because of that, we have 1.497 times 10 to the power of 8 kilometers because it was distance. You could have also looked at this problem and said they want my answer in scientific notation. So the first thing you could have done was convert those original numbers into scientific notation. The decimal point in 300,000 is at the end of the number, and we want our new decimal point in between the 3 and the 0. When we move, that means we're going 5 spaces to the right. So we have 3.0 times 10 to the 5th power. With our 499, our new decimal point needs to be between the 4 and the 9. So we'd be moving 2 spaces to the right. So we'd have our 4.99 times 10 to the 2nd power. When we multiply the number parts, the 3.0, or just plain old 3, times 4.99 to get 14.97. And then when we multiply the 10 to the 5th times 10 squared, the base stays the same, and we add the exponents to get that 10 to the 7th. But remember, 14.97 is too large. It has to be in between 1 and 10. So we need our decimal point to be between the 1 and the 4. So to go from our new decimal point to our old decimal point, we need to go 1 space to the right. So that's where that 10 to the 1st power comes from. When we combine these, because when we multiply, we add those exponents, we end up with that same final answer, 1.497 times 10 to the 8 kilometers. If we look at our next example, an influenza virus is about 1.2 times 10 to the negative 7 meters in diameter. A bacterium is about 1.5 times 10 to the negative 6 meters in diameter. How many influenza viruses would it take laid side by side to equal the diameter of the bacterium? So realize they're essentially telling us, hey, we have this big bacterium, and we know that our influenzas are smaller. So if we put one here, and then one here, and then one here, and we just kept going, they're asking us how many would we need to go all the way across. That's what we're trying to figure out. So if we look at that, we're taking one large piece, that diameter, and trying to figure out how many things can we fit in it. When we do that, when we take something large and we break it up into equal-sized pieces, we're doing division. So that's how we know we should take that bacterium, the 1.5 times 10 to the negative 6, and divide it by 1.2 times 10 to the negative 7th. When you divide the number parts, the 1.5 divided by 1.2, you end up with 1.25. When you do our fraction, we're dividing our 10 to the negative 6 divided by 10 to the negative 7th. Remember, we're doing negative 6 minus negative 7. When we have a negative minus a negative, we do same, change, change. And that -6 plus +7 give us that power of 1. So we can say that we have 1.25 times 10 to the first power viruses, because they were asking us how many viruses. But notice they don't ask us for our answer in scientific notation. So if we're trying to answer in decimal notation, that power of 1 is telling us move that decimal point to the right 1. So we'll actually have 12.5 viruses. If you have any questions, please feel free to stop by my office hours or shoot me an email.